So, friends, now let's dive directly into the topic what reinforcement learning can do for robotics. So, before getting into details about reinforcement learning, first let us see how our conventional machines, that is, our computing machines, and our conventional system were working. So, we used our conventional machines or the computers, so called, for solving any given problem. So whenever we have any numerical problem that our machine can solve, then we take up a process called programming. So the process involves multiple steps like we have a problem, we understand the problem and try to uh, frame the rules how our machine can solve the problem. Because human have their own intelligence, human have what we call knowledge accumulated over the past, and using this past information, past knowledge accumulated, and the intelligence, a human can solve problems. But when it comes to a conventional machine, it lacks the intelligence, it lacks knowledge, but what it has is power of computing at a very faster rate. So to make use of this faster computing, we have to convert our problem and try to analyze it and then see how our machine can solve this problem, and accordingly a set of rules are to be created for solving a given problem. These set of rules are often called the algorithm, and this algorithm is a human friendly way of telling how a problem can be solved step by step. And then this algorithm is not recognizable by the machine, therefore, it is finally converted into programming language, written in programming language, which we call a program. This program even is not recognized by the machine, therefore, internally, a program which we have written, called the high level language program, is further converted into understandable code by a tool called compiler. Once the code is compiled, we have machine understandable code, and that code is dumped onto the machine. So now we started with a problem. We try to understand how a machine with limited capabilities could solve that. So we created the rules, step-by-step rules, how it can be solved, and that is what we call algorithm. And that algorithm is converted into something high-level programming language by the human, and then the high level language programming language program is converted further into machine level language by some code which is called compiler, and this compiled version is dumped onto the machine, and now the machine can run this program, and whenever we put our query to this machine, it can provide us the solution. So what is great about this? So the great about this is the problem involved in doing all these activities. So the problem we have is to be solved by our conventional machine. So if at all you want to make our conventional machine to solve this, then we need to create appropriate rules called the algorithm, and then this algorithm has to be converted into a program, and that program is converted into machine language and finally dumped onto the machine. Once it is dumped, then the machine can take inputs and compute and then provide the solution for that. The major problem in this is the rules, the algorithm, and the dumping. All these activities are done by the human. That means here we are only trying to use the speed component of the machine. We don't have any intelligence added to the machine. We don't have any knowledge added to the machine. What machine is now doing is just computing at a high speed, but to compute that, it needs a program, and that program is created by the human. So to create that program, we do require algorithms, rules, and all these things are created by human. So as long as the problem size was limited, it was possible for human to solve the problem. But with time, we are getting into larger size problems. So when the size of the problem is growing, then the complexity of creating rules, the complexity of creating algorithm, complexity of creating the code, everything is becoming more and more difficult. So as the problem is increasing, say linearly, then creating the rules, creating the algorithm, writing the program, and everything is rising at an exponential rate. Therefore, it, the time has come where the human says, I no more can convert a solution to any given problem into machine understandable code. So it is beyond reach of human to program a machine to solve any given problem. But still, humans are able to do it, of course, at a slower pace, but still they are able to do it. Why they are able to do? One, they have intelligence. Two, they have built knowledge. So, with a vast experience, they have knowledge, and this knowledge helps human to solve the problem. Here, the human are not programmed as we program a computer. Here, the knowledge acquired by the human or the intelligence with the human is through a process called learning. So, what makes human different from a program or a computer is human are learning skills while the computer is running a program. So computers are programmed and humans are taught. So this difference, if we can reduce, that means if we can make a machine understand itself, if we can make machine learn by itself, then most of our efforts can be reduced, the human efforts can be reduced. So we just can define the problem and ask the machine to solve it. So for that, first we need to understand how we learn, and then we try to see how we can make our machine learn. So that's what we are going to see in our coming videos. So till then, take care. Bye.